Welcome to the NPTEL online course on fractals and multifractal. In the last lecture, we have discussed the influence of vertical scaling factor of fractal interpolation function. For that, we have chosen different type of constant vertical scaling factor, then how the constant vertical factor is affect the nature and pattern of the fractal interpolation function. Whereas while constructing the fractal interpolation function, we observe that there are two type of vertical scaling factors available. One is the constant vertical scaling factor, another one is variable vertical scaling factor or function vertical scaling factor. So in this lecture, we are going to discuss about the effect of variable vertical scaling factor of fractal interpolation functions. Let me start with the example. Now you can consider the data point is given here. For this data point, two different set of variable scaling are considered as follows. For the first one, for the here there are 5 data points are given. There are 5 data points are given here. Then for the 5 data point, as we know, we need a 4 vertical scaling factor. Here we are choosing the vertical scaling factor as variable, that means in the form of functions we are choosing. So here we have the line 0, 0.3, 0.5, 0.8, 1. So starting from 0, 0.3, 0.8 and 1. This example, in the previous example, while discussing the 0.5, 0.8 and 1. In the previous example, while we are discussing, we have taken x-axis values are in the equal distance, whereas here we are taking some non-equal points. That means xi is greater than xi plus 1, whereas the distance between xi plus 1 and xi are not equal here. Then here we have 1, 2, 3, 4 subinterval. For each interval we need to choose a vertical scaling factor. The vertical scaling factor will act on fi of x comma y equal to alpha x times y plus qi of x. In the constant scaling factor, fi of y equal to alpha y plus qi of x, where here the qi we are going to consider as a linear function in the form of cix plus di. This is the form we are going to consider. Fine. Now while choosing this vertical scaling factor alpha I, it should satisfy the condition that the maximum of this alpha I must be less than 1 over the region. Now we are choosing sin x by 2 on closed interval 0 comma 1. That means that alpha I of x, that means this function must be defined on the domain 0 comma 1, and if you are finding the distance, it must be less than 1. Norm of this function must be less than 1. Now we are selecting the first set of scaling factor as alpha 1, alpha 2, alpha 3, alpha 4, all as alpha of x as sin x by 2 plus 0.3. This function over this domain, it is less than 1. If you are finding the norm, it is less than 1. Now each interval, this is the function we are going to act. Then as I explained previously, what is the difference between this scaling, variable scaling and this constant scaling? Suppose we have the data point, we have the x1, we have the x1 here and xn here, and if you are taking any subinterval xi and xi plus 1, if you are choosing the constant scaling alpha, this if you are choosing the constant factor alpha, so it's control the fi over this interval Suppose if you are choosing any x between this interval, maybe I will take this one. If alpha will act on here, this whole interval, that means the whole data points, it will reduce the alpha times the whole. If you are taking any xi, we have to take the corresponding y, that means the line, the one has to take line like this one. For each value of x in this interval, we will get the line corresponding to the x like this one. If you are applying the scaling factor alpha and y, it will control this distance. That means if the straight line, this straight line has the length L, after applying this map, this length will be reduced as alpha time L. That means the length of, if this is the L, then after applying the map Fi here, then it will reduce to the alpha times L. Okay, that means throughout this interval, the alpha is same. Whereas in the constant scaling, if you are taking this constant scaling x1 to xn here, and xi here, and xi plus 1 here. Now, if you are taking any x, for example, if I am taking x dash here, that associated y values like this one, and x double dash is here, and associated y is like here, I can consider the same line maybe. Now, if this has the length L and this has the same length L, whereas if you are applying the constant scaling alpha I, it will reduce both the line by the scaling alpha. Whereas if you are applying this variable scaling, it will reduce the line L with respect to this x dash. That means alpha, this will be reduced to alpha I of x dash time L, and this line, this vertical line will be reduced to alpha I of x double dash time L. So, this is the difference between the variable scaling and the constant scaling. So, whenever you are choosing the variable scaling, the scaling factor alpha will be decided based on the x values. Whereas here the variable scaling is independent of the x value over the region, whereas here it is dependent on the values of x. So, here now for this example, we are choosing the alpha of x equal to sin x by 2 plus 0.3 over all this interval. Now, we are going to choose one more set of variable scaling. In each interval, different alpha is. In each interval, different alpha is. If you are choosing alpha 1 as sin 2x plus 0.1, that means here to here 0, 0.3, 0.5, 0.8 and 1. Here we are going to choose alpha 1, this function here, and alpha 2 will be made here, and alpha 3 will apply here, and alpha 4 apply here. Then what is the corresponding iterated function system? Fi of x comma y, maybe f1 of x comma y for the first one, sin 2x times y plus cix plus di in the interval 0 to 0.3, 0 to 0.3 for x belongs to this interval. In the f2, the function is 0.4 cos 2x times y plus cix plus di, where x belongs to the in the interval 0.3 to 0.5, where in the f3 of x comma y, the values 0.5 e power minus x time y plus cix plus di, where x belongs to 0.5 to 0.8. Whereas this interval, in the last interval, the f4 of x comma y, one can get x by 2 plus 0.2 plus cix times y Cix plus di. Now this is the iterated function system. There is no change in the Li, because Li we are going to change Li of x as Aix plus Bi. This is Aix plus Bi is our, because the vertical scaling, keep in mind whenever you are applying the vertical scaling factor, it is applying on the vertical direction, not on the horizontal direction. Therefore, it does not create any effect on the horizontal directions. Fine. This is the this f1, f2, f3, f4 all are the functions related with this 4 vertical scaling factor. Now, whereas for here, for in this case of vertical choice, for all fi of x comma y, we are choosing same scaling on the all the interval. Therefore, there is alpha 1, alpha 2, alpha 3, alpha 4 all are same. Therefore, we can get a single sin x by 2 plus 0.3 times y plus Cix plus di over where x belongs to 0 to 1. So, again here what is the difference? In each interval we are choosing different vertical scaling factor, that means different variable vertical scaling factor, whereas here in throughout the region 0 to 1 throughout the region we are choosing the same variable vertical scaling factor. Fine. Now, this is one iterated function system and this is another iterated function system. So, from this data point, by using the data point and the initial condition, one can find the contraction factor of this mapping Li as well as this mapping Fi as well as this all the mapping F1, F2, F3, F4. Then while combining, here we have two set of iterated function system, maybe I can call it as either F dash, then Li with F dash, here Li with Fi. So, this will generate one fractal interpolation function and this one will generate the another fractal interpolation functions. Now, you can observe here the first one, the saffron one shows the fractal interpolation function generated by the vertical scaling factor sin x by 2 plus sin x by 2 plus 0.3. For the same set of data, if you are choosing this variable scaling factor, one can get the fractal interpolation function like this one. Then now you can observe that the variable scaling here, the variable scaling is determined by the function this sin x by 2 plus 0.3, the variable scaling alpha 1 of x and alpha 2 of x all are depends on the value of x. Whereas in the constant scaling, what we discussed previously, you can see this is the previous example we have discussed. Here in the constant scaling, the variable scaling factor is the constant value 1 by 2, here 1 by 2, here it is 3 by 4, this is 3 by 4. It is never depends on the what we given in the x axis. So that you can just observe this two figure, there is more irregularity. Here also there is an irregularity, but it has some smooth structure. So, compare with the constant vertical scaling factor, variable vertical factor, choose the proper vertical scaling factor based on the x value also. So, if you are optimizing the proper way, then we can get the better or smoother approximation compared with the constant one. We cannot say whether constant is best or variable scaling is best, vertical variable scaling is best or constant variable scaling is best, because it all are depends on the data. Whereas, if you are using variable vertical scaling factor, it will generate the fractal in smooth structure, whereas if you are using the variable vertical scaling factor, it will generate the fractal by smooth parts or smooth self similarity, whereas if you are using the vertical scaling factor by a constant, then it will give the more irregularity. This is the comparison between the constant vertical scaling factor and variable vertical scaling factors. So, these two example one can observe the results. Thank you. We will discuss in the next lecture. Thank you.